Hello everyone, welcome to Natural Language Processing project using machine learning. And in this session, we are going to discuss about a project which is going to be a project with the help of our NLP using machine learning. And the title is going to be Sentiment Classification on Amazon Reviews using machine learning. So, like we know, Amazon or companies, these are called as e-commerce websites. These are a lot of companies which they sell products online, and they have their site where the customers can post reviews. Maybe, for example, if you look at Amazon, they have a bunch of products. It could be from different things. It could be a gadget, it could be electronic device, it could be a home application, it could be some tools or whatever it is. For each product they have a review. So mostly people used to do, right, maybe personally myself or others as well, when they go into the e-commerce sites like Amazon or Flipkart, and if they are interested to buy that particular product. But as we know, when you buy it in real world, like physically, if you go to a shop and if you buy, you will interact, you will test the product, you will try to look at it. But when you use it online, you don't know how it will be, right? The performance or the appearance or size may be relative here, but we don't know exactly what it is. So what you do is you have a review page, you scroll it down, so you will be going through the reviews which is posted by others, which tells whether it is useful for them or not. So this is from the user point of view. So the people used to post these reviews, and from the company side, they also need to take care of it, because if you have Amazon has a bunch of products and most of these products has negative reviews, then that will certainly affect this particular e-commerce company. So that's a problem which need to be taken care by the company also. So they want to focus on the products which are not good. So for these things, they can't go and read each and every reviews, right? It's a bit of tedious task. So we are going to use NLP because the reviews are text data. We are going to use NLP to classify whether it's a positive or a negative review, and then we are going to decide based on it by creating a model. So e-commerce site like Amazon get vast amount of feedback from users, and to go through all the feedbacks can be a tedious job, and you have to categorize opinions expressed in the feedback forums, and this can be utilized for feedback management system. And the performance sentimental analysis for this data help the organization to understand better about their customers feedback, so that they can concentrate on those issues customers are facing, and we build the model which has highest accuracy in classifying whether the feedback is positive or negative. That's what the task we have in hand. And talking about the data set, we have reviewer ID, user ID, reviewer's name, reviewer text, whether it's helpful or not, a summary, and overall rating on a scale of 5, and what time they have given the review. So these are all the contents of our data set. And going through the process, the usual machine learning process, we start with data collection, then exploratory data analysis, pre-processing, train test split, model training, evaluation and improvement, and finally inference with the endpoint which we will be using it to try to get a result. We'll make a predictive system. That's what the entire steps are going to be. So without wasting time, we are going to move into our Google Collab to start the contents. So let us connect to it, and let us upload the data set as well. So we have a musical instrument review data set. So Amazon is quite a bunch of things. You have a huge amount of data, and we are picking the musical instruments review, which is the review of products of musical instruments, and we are going to extract it first, and then we are going to see the contents inside and make it work by creating a model. So we'll start with this of extraction. So once the extraction is done, you will get the CSV file separately. From the zip file, we will be getting the CSV file, so we can read that CSV file, and we'll import the required libraries as well. And let us go and view the data as well. So looking into the data.head, we have the reviewer ID, their user ID, reviewer name, whether it's helpful for people or not, the review text what they are given, this is a gem for us, because this is where exactly the heart of NLP lies, right? So this is our raw material which we'll be focusing. And the overall, this is a rating out of 5 which has been given, 5 4 3 2 1, maybe it's available. And a summary of text, so you have a summary now, summary as well, which tells whether it's good or bad. It's a summary of the review text and the time and all. And as we know, we are taking it as a NLP data. Okay, so you are not going to predict the sale of a particular product or boost of a particular product. Our idea here, or our target, mainly focusing on mapping it whether that review is a positive or a negative one. So for in that sense, we need the review text, we need the rating to map, and then the summary, because we don't have a column known as the sentiment which is positive or negative. Maybe we have to extract it. So if the people have given high rating, then we can take the review as a positive one, and if the rating is less, then we can absolutely tell that the customer is not satisfied with the product. So the review text will contain the expressions of their like the product is not good, so they are going to express their feelings there. So we will be taking that, and summary is also a text. So we can go with these 3 columns, which can be a good raw material for our further processing. And apart from these, we have other columns as well, and we are not focusing on that. We are taking it as an NLP task. So we select those columns alone. So those triple columns are taken, and if you look at the head, this is what our data set is. So we have our review text, we have the summary, and we have the overall as well. So from here, first let us see a text. Maybe if you use locate, let us do a basic exploration. So we have our review text, summary. Summary is the best cable, and if you look at the review text as well, let us go and pick our review text here. So what has been written overall? So good that I bought another one. Allow the heavy cord and good connectors. Bass sound great. I just learned last night how to coil them up, and I guess I should read instructions more carefully. But no harm done. Still works great. And the summary is the best cable, so it works well, and the rating he has given is 5.0. So it seems like okay. So this is some data set. Maybe if you look at something else. Okay, this is also a rating of 5. So yeah, say details about musical instruments, right? So we may get, okay, this is 2. So maybe this is a negative review. So let us read it. So not 2 weeks after I put these string broke. Okay, so there is some broke, and he is expressing about what happens and how it was not good. So that's what the text here is going to tell us. So that is a text which is having some reviews, and the summary is also taking some small details, but once again the overall can be considered for mapping the sentiment. So we need to understand what all things we have in our overall, so we can go with value counts to check how many we have in our overall. And we have the rating 5 has been given for products, nearly 6,938. The rating 4 has been given to 2,084 products. The rating 3 has been given to 772. The rating 2 has been given to 250, and rating 1 has been given to 217 peoples. And with these, what we can do is our task is here to manage it either as a positive one or a negative one. So in that sense, we have a rating. So we are going to just denote the ratings who is greater than or equal to 4, which is 4 or 5. We are going to denote that as positive. If it is less than that, we are going to tell it as negative. So we can use map and call lambda to apply it, and doing this will replace that. And if you look at head now, the overall has now positives and negatives. And if you look at the overall dot value counts, we'll be getting nearly 9,000 rows of positive data and 1,200 is negative. And we can clearly see that there is an imbalance which may result in the less accuracy of the model performance. So So we have to leave it and see later on when we try to evaluate and improve it. Now we understand that there's some mistakes here, which is the imbalance. We'll deal it later. So going into info, we have a limited info, and it seems like there are some null values coming out here. So in the review text, so if you check the null values or dot sum, you have 7 places where you have null, and we can drop those, and we can go with the just remaining things. So describe here won't have any numerical column, so it is just going to give you a text summary of what's the total count, which is the top value which appears unique, how much unique and all, which is the frequency most, and positive is there in 9015. The word great has been found in 42 places. That's the most frequent summary you ever get here. And the text you can't tell. Here it's a continuous text. It's just randomly poking it out. So now we are going to select some of the, we are in data exploration. So we are going to select some of the review which has positive. So if you once again select this single column, you will get the overall. We have negatives and positives. If you go with positive, it is going to give you true wherever it is positive, and if you pass the entire data here, it is going to give you all the reviews which are positive. Similarly, if you do it by changing it for negative, you get for negative as well. So this is the reviews of negative. So what we can do is we can store the positives and negatives separately. And we have a library called as word cloud. From you can import this word cloud. So with the help of matplotlib and this word cloud, we can plot a lot of detail. So first plotting with a figure size, with the minimum font size, maximum number of words, the width and height. We are going to use this object to generate. Okay, so the text I'm going to pass is a joined version of this summary. So if you just get this data of summary, I get the summary column. It's a series, it will be coming, and now using join, it is going to take and combine all these sentences into a bunch of paragraph. And using plt.im show using matplotlib, if we plot it, we will be amazed to see the result. It will be very nice because it is going to show you a word cloud with a lot of words with different sizes, and these sizes tell that how frequent the word are repeating. So a word with bigger size will have most frequent word, and a word which is very small won't have that much. So we are going to generate this. It's generating, and this is what a word cloud result is. So this is the entire corpus. We are passing the entire data, not the positive or negative. We are passing the entire data, and we know that it's a musical data set. We can see the word guitar, we can see nice, best, works, great, pick, well, bad, good value, great, good work, use, tuner. Okay, so we have a lot. Great product, excellent. So this is what the text you have in your hand. It's a review data set, right? So you have the words of review. So you can see the word great is bigger because it's the most repeating word, and the other words, if they are smaller, then they are not repeating that much. And similarly, we are going to pick the positives, okay, from the positive summary and the negative summary as well. Let us see the positive and negative summary. Let's give it time to generate. In the meantime, let us explore this further more. So can we find any other musical instruments name here? We have a tuner, the word tuner. Okay, fine. Maybe metal is there. It's a review, right? It's a summary. Maybe if you look at the review text, you may get. And this is what the positives. So you can see cheap, amazing, quick, smooth, wonderful, great, perfect, price, nice, awesome, best, good, excellent, easy, sound, inexpensive. So you can see all the words which you tell to express that it's a great product, well built. Okay, so you find these words in the positive. Similarly, if we look at the negative, we have some positive words as well as, see here we have good, better, nice, okay. Okay, bad is bigger here, it's repeating a lot. We should have few more words. If you search, you can find amp, mic, beware, okay, junk. So these are some of the words which noisy. So these are some of the words which you tell you are disappointed. Okay, you even have a word called as disappointed, enough, nothing special, Okay, so these are some of, you can see pure poor quality and also these are some of the words which tells that, which conveys a negative feeling about the product, right? Something like beware, or it is having issues and all, distortion, okay, avoid, heavy. Okay, so these are some of the words which is in our the negative data as well of the summary. So now looking into the entire data, it seems like the summary also holds some information. What we can do is you can first build a model with review text and check its performance, or you can do it with summary and check its performance in the improvement part. And let us focus on combining these two into a single column. We can just concatenate the string. So if you just combine the string and put it together, so if we create a new column by combining these two, we'll get both. We can just concatenate with a simple space, and that's what we are doing. We are combining the review text with summary with a space, and we are storing it together back there. And once it is done, it's simple for us. We have combined it, so the summary is not needed now, it's added here. So we can drop the summary as well, and this is what our data which is left. We have our review text and we have the overall, which is the rating. So once again, now it's the time for text pre-processing, and for that we need NLTK corpus, stop words, string for punctuation, and NLTK, and let us download all. And we are creating a set of stop words English, and the reason is the stop words may have duplicates, and the set will help you to keep only one entries and not the duplicates. And we are creating a list of punctuation, and we are updating the stop as well, which means you are creating, like in the stop you are going to have your stop words as well as the unnecessary punctuations. So running these two, we'll keep it ready. At the same time, we know that if you perform lemmatization, we may need some process which is going to be the finding of the parts of speech of it. So it will give you the starting letter. With that you can find whether it's adjective or a verb or a noun or adjective or noun. So you can find it as we used to do in our parts of speech for lemmatization. Like we used to do, we can create this function, and once you've done that, we need a wordnet lemmatizer and a parts of speech tag from NLTK, and we create an object for the lemmatizer, and we can create a function for lemmatizing word and the final text. Every word you are passing, it is going to split the text, convert it into lower, and then it is going to check it is not in stop. If the word is in stop, it is going to just skip it. If it is not in there, you will be getting true, which means it's a word you have to consider. You find the parts of speech, then you pass it. Since it will give you a tuple, you pass it and get the extract information which we require. So it is going to give you which type it is, and based on it the lemmatization will happen, and the final text will be converted into lower and appended in this list. So finally, once it is done with the space, it is going to just join the final text and give you back. And running this on a sample, we will be getting some text. Maybe we will run with some other sentence. So this is what the pre-process to one looking like, and let us go with this. And this is, you are applying for a single text, but we need to apply for this entire series. So we can use map and pass a function, it will be getting applied there. So passing this will do the job, and it is going to complete it. So once this mapping is done, the text pre-processing on the text level is over. Next step is a conversion them into vectors. That we can do with our vectorizers. But before that, we also need to take care of positive or negative. For our convenience, we have named it as positive or negative. We can turn it into 1 or 0 so that it will be convenient for the model as well. So that's the task we are going to have, and we can proceed with, for example, let it complete. It will take a lot of time because the data set is having nearly 10,000 rows, and it has to apply it element wise on each of the series. So once it does and replace it, takes a text, do the process and replace it, and so on. So once it is done, we can go and map the overall. If it's positive, I'll turn it into 1 and negative as 0. So we can do it. And once it is done, once it is completed, we can get the head and visualize it. With this process, the basics are over. We can separate them into X and Y. X having the features, which is the text, and Y having the target or the respective label. It's a binary classification problem. So after this, we will be turning them into arrays and proceeding further. So this is the process completed. This is the text, which is of output, and we can separate them into X and Y. So we have turned the overall as well into numbers. Now if you look at the X, we will be having the review text. This is what our review text is. And yeah, so this oversampling is not for now. We'll do it later on when we need to actually do it. So for now, we have to look at our X and Y. So X is ready and Y is ready. So now it's time for us to turn them into numbers. So for that, we will go with feature extraction dot text from sklearn. We can import tf-idf vectorizer, and with this tf-idf vectorizer, we will pass the n-gram range, which is also 1,3. So it is going to use the unigrams, bigrams, and the trigrams included, so we can convey the information as well. So we can fit and transform the review text, and this will give you a sparse matrix. And once that matrix is done, if you look at the shape of it, you can get this is what their structure is. And the transformed one is available, that we are storing it in x underscore tf. That's the feature. So we'll pass the x underscore tf and our y value, and we use train test split with test size of 0.2 and random state 42. And now we are going to use the first algorithm. We are going to use naive Bayes. There we are going to use multinomial naive Bayes. It is an algorithm which works based on probability. Which output is most probable, it is going to give you based on 0 or 1, it will find. And we can use multinomial naive Bayes or naive Bayes algorithms work well with the NLP tasks. So we go and fit the model with the x train and y train values, and we'll make some predictions here, and the predictions will be zeros or ones. And if you look at the y test, you have it, you just have to correct it, and we can go with the accuracy score. And if you look at the score, it is 88%. So if you just look at the 88%, it was good. Anything more than 85 or anything nearer to 90 or more than that will be a good model. But don't get fooled by this. The problem here is it is working really good. It seems like it is having 88%. Let us do some more things like confusion matrix and classification report. And we can also have Seaborn as well. SNS. So once we have it, let us pass the same details and first print our classification report. So once you look at the classification report, you can understand the precision of the zeros and ones. Okay, so you can see it is completely, it has predicted the 1 properly, and 0 it is drastically went to 0, because here your data, if you look at what is this 88% correct is, it has exactly predicted everything as 1, nothing as 0, because that's what your distribution is also is. If you look at your y value count, you have 9,000 places of 1 and 1,200 of 0. If you divide it by your data dot shape of 0 and multiply this with 100, you get that 88%, 87.91, and that's what you have here. Okay, so all the 1 has been predicted correctly and zeros has been predicted wrongly as 1. You can get the same thing with SNS.heatmap, and if you pass your confusion matrix from metrics and pass your y test and predicted 1 with format of 0.0f, annotation equal to true. There is no need of decimal point here. So 0 correctly predicted as 0 in 0 places. Okay, and our data itself is small. You can see when you split it into 0.2, the data itself is very low. Let us try with 0.3 then. The data which has 0 in y train and y test is very less. That's a problem. That is also a problem. So y test dot value counts. So nearly 300 places now. Now we will fit the model and predict it. accuracy score is 87%. Still the model is failing in those particular areas. So all of those things are wrong predictions and giving us improper results for us. So it's better to move towards some other way which we can do. And here the problem exactly why we are facing this is the only reason behind this is our imbalance. So you have a huge imbalance which is causing the trouble here. So for handling an imbalance, we can use imbalance, which is a library which is used for either undersampling or oversampling. And using imbalance, we can perform oversampling using smooth technique, and we can set a sampling strategy of 1 and let us fit and resample. And once resampled, our data will be having equal amount of zeros and ones, and the reason is they use statistical techniques to slightly vary the data and create fake data so that it resembles the real, as well as you have some fake content so that the output matches. Now they have some equal content now. So let us perform the train test split and fit and predict the model. So you can see now it is towards 99.4% accuracy. So that's what the advantage of this as well. So that's how this model works well, and the reason is now you have balanced data and they perform really well. And let us see first data, which is, let us make the inference now. So you can see this is overall of 1, which is a positive review. So let us get the review text and train our model with this, try to evaluate it. So we have written about this, maybe we'll just copy the problem here and let us run this. So this gets your input, lemmatized words, that function, pre-processing will be done, array will be transformed into TF-IDF vector, and then the predictions will be done. So let us paste this review here. It tells that it's a positive review, and let us look at another review where this is negative, right? Let us pick one guy here from the negative. We have already separated them. Okay, let us run it. So you can see it is predicting them as negative, and it has nearly 99.4% accuracy, which got the tune here for this particular data set. And whatever we have tasked, we have completed it successfully. And especially we have to be careful when the accuracy may look high, but if you try to evaluate it, you can find there is some discrepancy with the imbalance or some details which is going to cost us down these problems. So we can do some alterations and evaluate this model as well. And one such thing would be like dropping the review text and taking only the summary, or dropping the summary and taking only the review text. With those things we can fine tune this. You can do it as assignment, we can fine tune this in those ways. And especially we can fit and evaluate with multiple models. Here on testing data it is doing further well, but if you give a new set of data, maybe let us try with our own text. Let us try to give a review of this product is great and it is worth of money. That's a positive. Maybe I'll write another review that I am really frustrated about this, such a waste, don't buy this product. It's a negative sentence, so our model works well for this data which we are giving, and we are particularly expressing a lot of context like the negative words such as frustrated, waste, don't buy. So these are some of the words which is going to have this convey of giving the pick towards negative as well. Maybe we can try to give a neutral word and see whether it is going towards positive or negative. Really don't know. Let us give it in a confused state. Really don't know. Maybe we can use it temporary. It's a negative anyway, right? So you are not that much confident with the review of this product. So in such cases, it is going to be some negative kind of review and the model is predicting well. So that's it about this session on predicting the reviews using machine learning, sentiment classification on Amazon reviews using machine learning, and